Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 8, lesson 10. Applications of the Pythagorean theorem. Which estimate is closest to the actual value of the expression? Explain your reasoning. Well, let's think about this. First, 4 squared is 16, so that's not that close. 5 squared is 25, that's very close. 4.5 is going to be in between them. So which will be closest? Because the square root of 24 is likely to be very close to the square root of 25. I would say this is closest to 5. Now let's check that. 24... square root of 24 is 4.89. Square root of 7. 2 squared is 4. 3 squared is 9. 7 is closer to 9 than it is to 4. So it will probably be closer to 3 than it is to 2. But what about 2.5? Square root of 7 is kind of in the middle of 4 and 9, so I would say 2.5. Let's check it. 2.64, that is closest to 2.5. Couple more of these. 42, square root of 6 is 36, square root of 7 is 49. 42 is just about in the middle of 36 and 49, so I'm going to say that's closest to 6.5. Let's check. Square root of 42 is 6.48. So that's definitely closest to 6.5. Ooh, this next one's going to be tricky. Square root of 10 plus the square root of 97. Well, the square root of 10 is going to be just a little bit more than 3. The square root of 97 is going to be just a little bit less than 10. So a little less than 3 and a little more, or a little more than 3 and a little less than 10. I'm going to guess that that is closest to 13. Let's check and find out. Square root of 10 is about 3.16. And the square root of 97 is about 9.85. What if I add those together? 13.00. I was right. That's closest to 13. Cutting corners. Mai and Tyler were standing at one corner of a large rectangular field and decided to race to the opposite corner. Since Mai had a bike and Tyler did not, they thought it would be a fairer race if Mai rode along the sidewalk that surrounds the field, while Tyler ran the shorter distance across the field. So one of them will be running straight across and one of them will be biking on the sidewalk. The field is 100 meters long and 80 meters wide. Let's label things. Tyler can run at about 5 meters per second. Mai can ride her bike at about 7.5 meters per second. Well, first we have to figure out just how far Tyler has to go. Mai has to go along the edge, so 80 meters plus 100 meters. So Mai has to travel 180 meters. Tyler has to travel the diagonal. Let's use the Pythagorean theorem to figure out how far that is. 80 squared plus 100 squared equals c squared. 80 squared is 6,400. 100 squared is 10,000. So 10,000 plus 6,400 is 16,400. So now to figure out what c is, this distance, we have to take the square root of each side. And c is about 128 meters. So now we know how far everyone has to travel. Ooh, we should have talked about this a little ahead of time. Before making any calculations, who do you think will win? Well, Maya's going faster. Tyler is going less distance. So does the distance or the speed they're going have a greater effect on who wins? Let's try to calculate this now. If Mai goes 180 meters and she is going 7.5 meters per second, we have to figure out how many seconds she was going. It took Mai 24 seconds. Now, Tyler has to go 128 meters and at 5 meters per second. .6 seconds. So who won the race? Well, it sure looks to me like the person who was traveling faster but more distance won the race. It was actually a pretty close race. Very different speeds. This person's going 1.5 times the speed of Tyler, and only won by 1.6 seconds. So who won? Mai won. Show your reasoning. That's what I just did up there. A calculator may be necessary to answer the following questions. Round the answers to the nearest hundredth. If you could give the loser of the race a head start, how much time would they need in order for both people to arrive at the same time? Well, we need Tyler to, because Tyler was the loser, we need him to shave off 1.6 seconds. So if he's going to shave off 1.6 seconds, how far would he travel in 1.6 seconds? Well, he's going 5 meters per second. So that's 8 meters. So Tyler was slower, but if you gave him an 8-meter head start, they would both arrive at the same time. If you could make the winner go slower, how slow would they need to go in order for both people to arrive at the same time? Well, we know that my has to go 180 meters. And for her to go slower, she has to do it in the same amount of time that Tyler did. So we have to go 180 meters in 25.6 seconds. So 180 meters in 25.6 seconds is 7.03 meters per second. So my would have to go 7.03 meters per second for them to arrive at the same time. Internal dimensions. Here are two rectangular prisms, K and L. Which figure do you think has the longer diagonal? Note the figures are not drawn to scale. So the diagonal of a figure goes from one vertex, one corner, to the opposite vertex across. To figure out just how far that's going, well, let's look first. If this one is 5 by 5 by 5, how long do we think that would be? If this one is 6 by 4 by 5, well, this one's got one longer number. It kind of looks longer in this picture. So let's guess this one, just because it looks longer in the picture. Now let's do some math and calculate this and figure out which one's longer. Let's find the exact length of these diagonals. So now, if we think about what this diagonal is doing, what is this going to look like? Well, this is kind of a right triangle. From there, using this height, this diagonal across the base, and then this is our hypotenuse through the middle. We know this side is 6 meters because the height is the same on each side, but this line here, we actually have to use the Pythagorean theorem using this side length and this side length to find out what this is. How do we find out that length? Well, a squared plus b squared has to equal c squared. So 4 squared plus 5 squared has to equal c squared. 4 squared is 16. 5 squared is 25, has to equal c squared. 16 plus 25 is 41. So the square root of 41 is c. So this length here is the square root of 41. Ooh, well, now we need to figure out this diagonal here. We know this side and we know this side. So we have to use the Pythagorean theorem again. The square root of 41 squared plus 6 squared equals the diagonal of k. So I'm just going to call that k squared. Square root of 41 squared is 41. 6 squared is 36. (41) plus 36 is 77 is equal to k squared, which means k is equal to the square root of 77. I'll label that on here. That diagonal is the square root of 77 units long, which is approximately 8.77. Now we have to do the same thing for L. we need to find this length. That leg and that leg are both 5, so 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. 50 equals c squared. So the square root of 50 is equal to c. Now, that's 5 because it's the same as this height. Use the Pythagorean theorem again. The square root of 50 squared plus 5 squared equals, let's call this one L. Square root of 50 squared is 50. Square root of 5 squared is 25. 50 plus 25 is 75 equals L squared. Find out one, square root each side. So the square root of 75 is equal to L, which is about 8.6. So let's just look at these. They're actually fairly close. The square root of 77, the square root of 75. Which one is longer? Well, it looks like our initial estimate of the one that looked longer in the picture was longer. Not by much, though. So the length of this one is the square root of 77. Okay, our summary for this lesson. The Pythagorean theorem can be used to solve any problem that can be modeled with a right triangle, where the lengths of two sides are known and the length of the other side needs to be found. For example, let's say a cable is being placed on level ground to support a tower. It's a 17-foot cable, and the cable should be connected 15 feet up the tower. How far away from the bottom of the tower should the other end connect to the ground? It's often very helpful to draw a diagram. We have a right triangle. There's a tower that's 15 feet tall. We have a 17-foot cable. Since it's a right triangle, the relationship between its sides is a squared plus b squared equals c squared, where c represents the length of the hypotenuse, and a and b represent the lengths of the other two sides, the legs. The hypotenuse is the side opposite the right angle. Making substitutions gives a squared plus 15 squared equals 7 squared. Solving this for a gives us an a value of 8. So the other end of the cable should connect to the ground 8 feet away from the bottom of the tower. Okay, this has been another episode of Mr. Boskin Does Some Math. Thank you very much for tuning in. See you next time.